Hello and welcome back to Steam with Steve. We're going to keep going with our Pythagorean applications and do a couple more sort of examples of these harder problem solving questions. Now these ones here are a little bit more difficult than the ones we've done previously, so if you haven't seen those, please go back and watch that video first. So let's jump on in. So hopefully we all remember the rule, h squared is equal to a squared plus b squared. And when we do these Pythagoras questions, the biggest hint is to redraw out a quick little picture of the triangle or the situation. And then that way you label the sides so you can get your head around what's happening in the little game that you're about to attack. So this is another example that I've sort of put together. So you find a treasure map that gives you the instructions to a treasure chest. Start at the palm tree under a waterfall. You must then move 340 paces east, 873 paces south, 632 paces east, 2,135 paces north, 3,372 paces west. If the pirates back in the day used a measurement called the braza, and one braza equals 1.7018 meters, how many meters is the palm tree that the original treasure was hidden, that you started at, to the treasure chest? So just pause the video. My hint is to try and draw that out. So draw the measurements out and see if you can get it. Cool. So what happens is we should know never eat soggy Weet-Bix. So north, east, south, west. And basically we want to work out which way to go. So if we're at this palm tree, first of all, we want to go 340 paces east. Then we want to go 873 paces south. Then we want to go 632 paces east. Then 2,135 paces north. And then lastly, 3,372 paces west. Now, this question was asking how far away was the treasure chest from that original location. So we started there. You would have this red line, which is the distance. Now, unfortunately, this isn't quite yet a Pythagorean sort of question because we don't have a right angle triangle. But if you look carefully, you can make a triangle in the middle here if we just went straight up here. So we need to find this distance here as if we go straight above the palm tree, and then also this distance across here if we just went straight across. Now, if we think about this, because we've got two dimensions, the up and the down, or the north-south and the east-west, we can work out the absolute value that you've gone in the east and the west, and then the absolute value in the west, north and the south. So to work this out, we need to work out this horizontal distance across, and then this vertical distance down and up. And the easiest way to do that is just look at the triangles and then look at what the measurements have. So for the vertical distance, we know we've gone down 873, but then we've gone back up 2,135. Now, because we've been doing our directed numbers, we should see a pattern there. So we should understand that this distance here with the vertical distance is the 2,135 minus the 873. Similarly, this distance from here where the treasure chest is across is the same as the whole distance, the 3,372, but then we minus the 873 and the 632. So the horizontal distance there is equal to 3,372 minus the 340 minus the 632, which gives us 2,400 paces. The vertical distance then is 2,135 minus the 873, which gives us the 1,262 paces. So that gives us the two things measured in paces. Now we've got our little right angle triangle because the compass works perfectly in 90 degrees. So to find that distance, we then just use Pythagoras. So to do that, we go h squared is equal to a squared plus b squared. We fill in what we know. So we want to find the distance, which is why I've used d instead of h here. And we go equals 2,400 plus the 1,262. We then square both those numbers, which gives us a really big number of 7,352,644. And then we square root that number. So that equals 2,711.58 paces. Notice that I put the measurement at the end here. Now the question here, this is where the trap is, how many meters is the palm tree from the treasure chest? Now you could have converted these braza if you wanted at the start, but I like leaving that at the end because we've got nice whole numbers here. So to find that, the last step, we need to then do 1 pace is equal to 1.7018 meters. And it's pretty simple. We have that many paces. We literally just times that by 1.7018, which then gives us the 4,614.56 meters. That's sort of a really cool problem solving question. Now you'll see there's layers here. If I gave you just the words, it's a little bit harder. And then if I want to make it a little bit easier, I would give you the diagram. So the original diagram. Then there might be other things inside here that I might give conversion rates, all those different things that you need to look for the problem solving. My hint, this is absolute gold for you for doing problem solving. So when doing this, I would highlight all the different keywords, all the measurements, so the 340, 873, just so that your eye doesn't have to get as strained and you're trying to work through this. Cool. So the next question we have is a little Batman question, because obviously I'm a bit of a nerd. I love Batman. And we're going to do a Batman question. So Batman is standing on top of a 670 meter building at the very north end. So he's up the top of this building. He sees the Joker driving like a maniac down the road. So it goes down. He then shoots his grappling hook and a diagonal down to the absolute bottom at the very south of a 340 meter building across the road. If the buildings are 100 meters apart and are directly opposite each other with the same width of 50 meters, how long is the cable Batman will need? So just pause the video, see if you can do from this level. Right, so then the next level would be if you could redraw out what had happened. So here's my quick little drawing of two buildings opposite each other, and Batman's at the top of a 670 meter building. So he's at the very top here at this corner, and then he's going down to this bottom of this building. Now, the 340 meter building there, that's actually a bit of a trap. You don't actually need that measurement. It's there just to throw you off. It's very important. Sometimes you need to discern what is the important measurements here. So that's 670, that's 50 meters across. And then the width of both these buildings is 50 meters across as well. And then the buildings are 100 meters apart along the ground there. And look at that. We've got a right angle triangle, another right angle triangle, and then this is very similar to the cube question that we did, I think as example number 2 in the previous video. So by drawing a quick little diagram like that, that might help. Not might, it will definitely help in your process. So just pause the video here and see how you go from that. Awesome. So what you should have found is you would find X first, so that using a right angle triangle with the 50 and the 100, then you would use the 670 and the X measurement that you found to find the length of the red grappling hook going down to the bottom, or Y. So if we looked down with a top-down perspective, this is what Batman would see. So this is 50, this is 100, and he's up here at the top corner. So by drawing this out, it doesn't have to be as detailed as what I've done here. It does help a whole heap when you're trying to work through these type of questions. So you go h squared is equal to a squared plus b squared, x squared equals 100 squared plus 50 squared, x squared equals the square root of that, so the 12,500, which gives you 111.8 meters. So if you went at the very base of the building from this top corner, the very base at the southern corner of the other building, that's 111.8 meters across. Now that answer seems reasonable if you've got 50 and 100, so we can use that for the next calculation. So we now have that as 118.8, and we should be able to see that there's a new triangle here with a right angle. So we've got 118.8, 670, and we want to find y. That's just straight Pythagoras again. So looking from this perspective across here, we have this. So if we're looking at Batman there, shooting down the grappling hook, we know it's 111.8 and 670. We would just use straight again Pythagoras. So h squared equals a squared plus b squared, y squared equals that, and then we just do the square root of it and we get 679.26 meters. Hopefully that's made some reasonable sense for you, and that's literally the cool little problem solving example that I have. So Batman will need a 679.26 meter cable. So that's it for me. Have a go at the next worksheet. There is a lot more challenging sort of questions in this. This is as hard as it gets. There's a challenge question at the end called question 10. And yeah, that's it from pretty much from me. Awesome. So hopefully you've enjoyed that. You've picked up something to use with Pythagoras within inside of the problem solving questions, and being able to read through the question to discern what's important and what's not necessarily important. That's it from me. Hope you've enjoyed. And yeah, if you did enjoy this video, please give us a like and subscribe down below, as it does help with that YouTube algorithm. And then yeah, adios. See you next time on STEAM with Steve.